Hello and welcome to Ask News, where we review and delve into the latest and greatest inside the world of astronomy. So today in astronomy, did we just discover the most distant known source of light? The Hubble Space Telescope spots this beautiful stellar nursery. NASA's Perseverance rover begins its exploration of Mars. And what we'll be delving into deeper today, the trio of black hole researchers who won the 2020 Nobel Prize in Physics. So let's discuss the 2020 Nobel Prize for Physics, which was awarded to Roger Penrose, Reinhard Genzel, and Andrea Ghez. The award is split into two halves, the first half going to Penrose for his contribution to the theoretical understanding and prediction of black holes. The second half is split between Reinhard Genzel and Andrea Ghez equally. Their contribution was to lead groups that have mapped the orbits of stars close to the galactic center. Their studies led them to conclude that an extremely massive, invisible object must be dictating the star's frantic movements. So while Penrose did prove mathematically the existence of black holes, the contributions of Andrea Ghez and Reinhard Genzel first showed us that there does indeed exist a supermassive black hole in the center of our galaxy, the Milky Way. Known as Sagittarius A star, the two teams, one led by Andrea Ghez off the coast of Hawaii, and the other by Reinhard Genzel in Chile, both observe that stars perform this orbit that can really only be explained by the presence of a black hole. They observed the orbits of these stars for nearly 30 years. And over the course of these 30 years, they calculated the mass and the distance of these stars, and they were able to assume that given the trajectory of these stars, there must be a black hole governing not only these particular few observed stars, but rather the entire galaxy. One of these stars, the S2, completes an orbit in less than 16 years. And so over the course of almost 30 years, they were able to map out two orbits of the star S2. Just to compare that to our solar system, it takes nearly 200 million years for the sun and the solar system to complete one orbit around the Milky Way. Now let's talk about the second half of the Nobel Prize, which was awarded to Roger Penrose. Penrose had his work cut out for him. To prove that black holes existed, which is something that even Albert Einstein could only theorize, but he hadn't really developed the math to be certain, Penrose needed to expand the methods used to study the theory of relativity. His article was published in January 1965, and it was groundbreaking. See, up until the 1960s, the solutions that we had to understand black holes were really theoretical speculations. They described ideal situations in which stars and their black holes were perfectly round and symmetrical, and nothing in the universe is perfect. And Roger Penrose was the first to successfully find a realistic solution for all collapsing matter, with its dimples and its natural imperfections. Let's unpack that. So the answer for Penrose actually appeared in the fall of 1964 whilst he was on a walk with a colleague in London. Penrose, a professor of mathematics at Birkbeck College, had the idea of a trapped surface, which was decently common in the sphere of mathematics. So this was a key that he had been unconsciously been searching for. A trapped surface forces all rays pointing towards the center, regardless of whether the surface curves outwards or inwards. So using this idea, Penrose was able to prove that a black hole always hides a singularity, a boundary where time and space, as we know it, break down. The density of this point is infinite, and the idea of a trapped surface became the key concept which allowed Penrose to prove the singularity theorem. He introduced topological methods which are absolutely priceless today in the study of the universe. Together, these three people made massive contributions to our understanding of black holes. Thank you so much for tuning in today. to Ask News, and I hope to see you again next time. Good night.